Hi, I want to talk about the total change in internal energy of water when it boils in its expansion from the space it would occupy as a liquid to the space that it would occupy as a gas. So I'm going to consider what happens with 1 gram of water at 100 Celsius. So as liquid water, it would be occupying a volume of roughly 1 cubic centimeter. As a gas, as steam at 1 atmosphere, it would be occupying a volume of roughly 1,600 cubic centimeters. So what happens is, as that gas sort of breaks apart, breaking the surface tension, evaporating, it has to expand from that 1 cubic centimeter space to the 1,600 cubic centimeter space that it occupies. So our change in internal energy from the first law of thermodynamics is going to be the heat added to the gas, which is the energy that we have to add to change the structure. So we need the latent heat of vaporization, which for water is 2,260 joules per gram. And then we would have to add to that internal energy the work being done on that gas. And this is going to be a case of isobaric expansion. We have atmospheric pressure. We're still going to have atmospheric pressure because a gram of water in sort of a real room space isn't going to significantly change the pressure. Now, if we're talking about inside a pressure cooker, that's a different story, but for now, we're just going to look at sort of that gas expanding out into the air. So, for the added heat, the energy of the phase transition is our mass, 1 gram, times our latent heat, not of fusion, but the latent heat of vaporization. And because we're going from a liquid to a gas, that would be a positive transfer of heat to the material. So we'd have 1 gram times 2,260 joules per gram. We need to add 2,260 joules to that gas to make it a gas. Now for the work, I said we're going to consider this an isobaric expansion. So the work done on a gas in an isobaric constant pressure expansion is minus the pressure of the gas times our change in volume. Well, atmospheric pressure is 1.01 times 10 to the 5 pascals, and our change in volume is 1,600 cubic centimeters minus 1 cubic centimeter, but to calculate a work in joules, we need to convert that over to cubic meters. So every cubic centimeter is 1/1,000,000th of a cubic meter. So we then multiply this by 10 to the minus 6 to convert from cubic centimeters to cubic meters, so we get a work in joules. And if I multiply those numbers out, I get a work of minus, because I have an expansion, the gas is what's doing the work, so the work done on the gas is minus 160 joules. So if I have 226 joules minus 160 joules, that means there's a transfer of 2,100 joules of energy into the gas through this process. Thanks for watching.